Hi all, this is a quick extension exercise for those who would like to add paths and other information about slopes to their Botanic Gardens maps. You may also find this useful for your final report. Today I'm just going to show you quickly how to make use of contour lines, which are vectors, to create elevation models, which are rasters. So that's what we're going to be doing today. The Queensland Government provides a 1 metre contour interval set of line features in GIS free of charge for everybody, and so we can use that to create, using GIS tools, geoprocessing, we can use that to create a set of rasters with elevation models. So today I have downloaded that. You'll find this file in week 9. I've just put it in week 9 lab section of Blackboard. It'll be in a weird long named folder like this here with just today's date and a code for the download, which is just Queensland Government tracking and keeping track of how many things have been downloaded and when. And you'll see that it's called contours 1 meter.shape. Okay, I've already selected it and requested it in 28356, and it should all be projected for you. So you can drag and drop this into a blank map. I'd recommend working with a blank map for this. And already in here you can see that we have the footprints of some of the larger buildings in QUT, the sound bowl music section here, the bank down to the river on the edge here, and you can see that there's some footprints of buildings and other things in the city where surfaces get very complicated. You can also see that we have a set of contour lines around our Botanic Gardens in here. So in order for us to convert this to a raster, which would allow us to calculate things like slope, we're going to use geoprocessing tools in the spatial statistics, spatial analysis toolbox. I'm just going to wait an hour for this to come up. So down here under spatial analysis tools, we have surface tools, and we should have, no, we don't have it there, so we will search for it. That's okay. We will come back to using features like slope in a moment. So let's just use our search bar to find the tool, which will be called Topo to raster. Okay, sorry, there you go, it's in 3D Analyst. Okay, it is also in Spatial Analyst. Okay, so in order to use Topo to raster, we need to provide some topographic information, so that's going to be our 1 meter contours. Now the 1 meter contours are just lines with an elevation attached to them, so they're equal elevation lines at 1 meter intervals from 0 meters. Okay, so we'll be using contour. If you see on the side here, input feature data, we're using contours. You can also use point elevations, you can add sinks, so points that drain, you can add boundaries, there's lots of other options that we'll have in there. You just need to set each of them as we go, but you don't need to worry about that at the moment. Here we go, so we've got our contours in, and it's going to output this to the default geodatabase. In your case, if you set up your ArcMap, well, that will be going somewhere else. I'm just going to set that to output back to the folder where this contour came from. For you, I'd recommend saving it somewhere where you don't have to do this again, because as you can see, it can take a little while to get to it. So let's just go down here, Documents, and I will just create a new geodatabase in here. the wonderful experience. You can see that even I suffer from ArcGIS slow access, and this will be called slopes. CBG. Okay. And so we're going to put it in here, and we're going to call it ELEV elevation raster. Now, ArcGIS thinks it knows best and divides the area that is available into 250 by 250 cells. So it's come up with a solution of 2.35 meters, which is quite messy. Now, we don't want super fine resolution because we're interpolating over a fairly large distance in some of these cases. So I think maybe a 2 meter raster is probably sensible, and we're going to output extent the same as our layer, which it should already be, but we'll just double check that. So on our drop down here, we wanted to set the range that it works over, and yes, we're all good there. Margin in cells, optional 20, that's fine. Smallest Z value to be used in interpolation. We will mark this down as -1, so we'll allow it to go slightly below sea level if it needs to, because there is low points in the gardens, but we don't want it to get too far down. We don't need to set a maximum. And then we've got our primary type here is contour. One thing to check up the top is to make sure that it's registered field as elevation. Just double check that one while you're going. Okay, a roughness penalty, you can put that in so you can have it smooth or allow it to find sharp edges like steps or walls. So we won't put a roughness penalty on this one because it's not a natural landscape. We do have, you know, retaining walls and other features that are hard edges. Okay, and you should be able to leave pretty much everything else the same and just click OK. Now, it's going to take a little while, but it's going to now process and interpolate between the elevation level of each of our contours to all of its neighbours and develop a surface model or a digital elevation model for our botanic gardens. You can see like features like O block and others where they've been cut into hills and built in, set in on the sides. Here we go. It's now processing. I might just pause it here because I'm not sure how long this is going to take on my little laptop, and I've got a time limit on my record time with the free screen share software. Okay, so here's our output a couple of minutes later for the contour lines. I'll just quickly show you what is in this data for contours. So if we just change the properties and symbology here for these two color code different elevations, we'll be able to see the patterns in the elevation model in the contours. Sorry. Okay, symbology, quantities, elevation. Okay, and we will make it, so we go from -19 to 17, so let's call it 20 and apply. And we'll make a color ramp that stands out a bit more, apply. Okay, so here we have our botanic gardens. We can see the higher section through here for QT, then back end of the music bowl. We can see the lower parts, and we can see the contour bank into the river. Now, if we look at our elevation raster here, we can see that it's been classified automatically for us and not necessarily into levels that we find useful. So we are going to quickly change that and go to properties, and symbology rather than classified we'll just say stretched, and apply. Okay, so now high areas are white, low areas are black. That makes sense. This is the water features down here, and across here is the lower section. Here's the levee bank at the river. So now we would like to calculate slope. So if we go back in here, we can search for slope and use the slope 3D analyst. Don't click on that. For those who want to read it, they can. And we're going to input our elevation raster. As you can see, I spent half of my life waiting for ArcGIS as well. Now, before making your slopes, I would recommend that you figure out from a quick internet search what version of output measurement you want. Some refer to it as rise on run, which we can calculate from percent. Others might have a slope in degrees. So work out what recommendation you're going to follow and choose the appropriate measurement units for yours. And in here we're going to call this our slope. Save. I'm going to set it as percent rise, and the method will be planar because for our area here it's going to be effectively a flat surface. We don't have to worry about curvature of the earth. And our Z factor is going to be 1 because we're in meters, we're not in a multiplier, and it's going to be meters. So I'll click OK. And now we calculate our slope. I'm just going to pause it so I remain time to show you. Okay, and here is our slopes based on our elevation model. You can see that there are a few other little artifacts in it, but broadly the areas around the water features down the bottom here have sharp edges on. We know that these are particularly steep banks around the edge, and this is just once again classified as a set of random values. So this is in percent, so you can convert these and select from that raster slope areas that are too big. Okay, that gets everyone started. I'll pause or end this recording now and post it up for you.